Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, we're working on that end of trimester 1 interim. We're going to be working on that wrap up for this as well. So what we're going to say is 3 line segments and 3 triangles are shown on the coordinate plane. Which of these line segments or triangles could be the image, meaning the new picture, of another after a sequence of rotations, reflections, and translations? And what that means is no dilations, meaning the size is the same. And so right away, I can kind of cross out some of my selections. I can say, hey, if I'm looking at AB and KL, that is changing in side length, so I know it can't be that one. However, I can say for B, I know that one's going to be good because it is a rotation plus translation. So if I'm looking at, what was it, AB to IL, again, I could rotate and then slide down. For C, it's saying segment IJ to KL, same idea. We say we can't do that one because it's a dilation. So again, no dilations, meaning our size cannot change. However, in part D, let's say CDE and MNO, same thing. It's a dilation, so it can't be right. Triangle FGH and MNO, same thing. But the last one, they are the same size, and so I could say it's actually a rotation and translation. So it's going to be those 2 choices for this one. So again, make sure you're careful on that one. Those rigid transformations, they don't change size. That's for dilation. So we're just asking about those 3 options. For number 2, it says figures E, G, H, J, and L are shown on the coordinate plane below. It says which figure can be transformed into figure E by reflecting across the Y and by translating it 1 to the right. So again, anytime I see that word reflection, reflecting, I could say across the y-axis. And so what I can do is I can actually highlight that y-axis, try that a little bit better. Highlight that y-axis, and I'm saying I have to go over or across that y-axis. I'm going from E over to here, and it moves 1 step to the right. And so that works out because if I'm looking at my distance from the y-axis, this is 3 steps, and normally you would say, hey, it's not right because it should be over here, but we said we went 1 step to the right, so this should be 2. So we're going to say it's going to be our figure L for that one. So we reflected it across the y, and then we went 1 step to the right. For number 3, it says describe a transformation that maps ABC onto the image triangle A prime, B prime, C prime. And it says, are the 2 triangles congruent? And we have to be able to write a sentence explaining how we know. So we're going from the image, or from the pre-image ABC to our image, our new picture, A prime, B prime, C prime. And so what I can write is this. I can say ABC and A prime, B prime, C prime are actually congruent. So I can say are congruent, and I can say because. Make sure you have a reasoning. So we say we can rotate, rotated 90 degrees counterclockwise around the origin, which is that point 0, 0. Again, we rotated, we picked our center of rotation as that origin, so 0, 0, and we rotate around it 90 degrees, or sorry, that should be clockwise. Let's say clockwise. So I always want to check. That way I'm good. So it should just be clockwise because we went around it, going with the clock. Notice how the points are flipped. So we had -6, +3, and now we have +3, +6. So we went from xy to the opposite of y and opposite of x. So they switched around and they switched signs. For number 4, I should say, it says on the coordinate plane below, the square ABC is dilated by a scale factor of 2, with the origin as the center of dilation to form ABC D prime. After the dilation, what is the location of C prime? So what I'm going to do is I'm going to find my original first. I'm going to find my original. So let's say C right here. So original is going to be C, which we have as the point 2, 3. Since I have this point and it has the origin as center dilation, I can count the number of steps that it is away from the origin, but it should be now times 2. So I'm saying I'm multiplying it times 2, so times 2 to get our new point. Let's do blue. Let's say our new point, our image, which is our image, as C prime. So multiply each of those coordinates by 2, so we're going to say 4, 6 should be our new point. I can label that C prime. And I'm saying, if I notice, I said originally I was 2 steps to the right. Now I am 4 steps to the right, and I said I was 3 steps down. Now I am 6 steps down. So that makes sense. Sorry, this should be negative and negative. There we go. So we had C prime is going to be 4, -6. For number 5, it says, look at the triangle JLK on the coordinate plane. It says we have to rotate 180 degrees about the origin and find the coordinates of L prime. So original is going to be, so L, my original is right here, so that's going to be -2, 4. And this is helpful because I know that I have to use these digits. So I know that it can't be this one and it can't be this one. So right away I can cancel out 2 answers because it doesn't have 2 or 4 in either of those 2 answers. And so what you can do is this. So let me write the directions underneath. I'm going to say draw a straight line. So straight. So let me back up. From L through, let's say through 0, 0, because that's my point that I'm rotating around. So again, I can draw a point through the origin. If I draw that straight line, it will tell me where my point or my new is going to be. So I can go from L the whole way through. Again, as long as it's on that line, I know I'm good. And so if I look at my options, again, I know it's a straight line because if we look at the way we rotate, it should be 180 degrees. So it should be half a circle. So it should be that straight line through that point. If it was 90 degrees, I could make a 90-degree angle here, but that's not the case. So if we look at our point 4, -2, that is over here, and that's not on the line, so I know it's not that one. But if we look at the point, let's say we look at the point 2, -4, however, we know that's going to be our new point L prime. So I'm going to say our new point is going to be L prime. So pick C for that one. For number 6, it says which of these statements is true about the two graphed figures. And we want to make sure that only, so let's say only pick one. So from these 4 choices, let's see what we can find out. And so what's going on in this picture? Well, just looking at this picture, I can say, hey, I know that my original figure is A, my new is A prime, B prime, C prime, D prime, and I noticed that it is changing size. But what I can say is, since it's changing size, so changing size, I know that that means dilation. And so right away I can say, hey, let me cancel out some of these options. So I can say, hey, it's not going to be this one because it just talked about dilation. And it's not going to be that one. Another thing I can find out is, let's find out if I say my original point A was 2, 8. So my original was that. And my new was A prime, which was 1, 4. So I'm saying, okay, what did I multiply by to get from my original to my new? Well, I'd have to multiply it by a number that's less than 1. So I could say my dilation, I can say with scale factor of 1/2. The reason why this works is because if I multiply each of these coordinates by 1/2, so times 1/2, I'm essentially going to get my new point. So that, again, it's half the distance away from my origin, so I know that A is going to be right. So I'm going to pick that top right choice as my answer. For number 7, it says a bakery prepares boxes of desserts. Each box contains twice as many cookies as brownies. Which graph shows the relationship between the number of cookies relative to the number of brownies? So what I'm going to say is this. I can say, hey, since it says twice as many cookies as brownies, that means I should have a function like this. I should have a function that's y equals 2 times x, because I'm saying my x, whatever my x-axis is, my y-axis should be 2 times that amount. So that means I'm looking for slope of 2. And so what I can do is I can kind of write some of these options. I'd say, hey, if I'm looking at this first graph, I'd say my slope for this one is 1/2. So I know it's not this one. For the second one, I'd say, hey, I'm going 1 to the right, 1 up, so my slope is just 1. So I know it's not this one. For my next one, I would say my slope is 0. It's that horizontal line, which is still not the case. However, for this last choice, I know that if I go 1 step to the right and 2 steps up, plus 2, and plus 1, I know that my slope is 2. So I know this one is going to be the one I choose. So make sure you're reading the question carefully, and you're saying, okay, I know that my slope should be 2 for this choice. So now it says, it's around. For number 8, it says the table, the graph, and the receipt show the cost of pairs at each of 3 stores. For each store, the relationship between the number of pounds and pairs is a direct proportion. That just means that I can write a ratio. I should be able to find out what the slope is, or the rate of change, if you will. Then it says select the order below. That shows the stores from least to greatest. And so what I can do, so let's say find unit rate, meaning I want the price over 1 pair, because that way I can figure out what each of these is. So I can say, well, in store C, I can say for store C, it's going to be equal to, I have 1.78 divided by 2, because it says for every 2 pounds. So I'm going to say that's equal to 0.89. So for every 89 cents, I get 1 pair. So that was store C. For store A, I'm going to say I have, let's see, it says $3.87 for every 3 pairs. So if I divide that out, I should get $1.29 for each pair. So 89 cents versus $1.29. And then lastly, we could say, let's do blue. And say for store B is actually going to be for every $2, I get 2 pairs, which is equal to 1. So the slope or the unit price, rate of change, again, each of those words are the same thing, is going to be 1. And so now I just have to say, okay, well, if I'm going to go from least to greatest, my order would be this. So smallest number is 0.9. So I have C. I'm going to say next number is 1. So I'm going to say B, and then A for my last one. So I'm going to say for this choice, I'm going to say it is this order. Again, least to greatest, make sure it lines up. Again, find your values, your unit rate, and compare them. For number 9, it says the gas mileage for 2 cars can be compared by finding the distance each car traveled and the amount of gasoline used. The graph shows the distance, y, that the car A traveled using X gallons of gasoline. The table shows the distance that car B traveled using X gallons of gasoline based. So we have both X and Y values match up, and we're saying, based on the information in the table and the graph, car A can travel how many more miles per gallon than car B. Show your work and explain your answer. So what we're going to do for this one, what we can do is we can look at the actual slope of each of these. So similar idea to the last one. I'm going to say, well, if I look at my slope or my rate of change, I'm saying, okay, if I go similar idea for this, for A, I can use this ratio. I can say, okay, it went between 0, 0, and my next point was 2, 50. And so what I can do is I can find my rate of change. So I'm going to say, okay, from my change in Y is 50, my change in X, let's do short blue, is plus 2, that was plus 50. And so I can find my slope, or my rate of change, so rate of change, have your Y value in the numerator, so I have 50 over 2 is going to be 25. So what that means is I get 25 miles per gallon. That's why we write that ratio like that, because I'm saying it's 25 per gallon. So for B, let's do a different color. Let's say for B, I'm going to say I have the 2 points, so I have 0, 0. Same setup, a little bit easier now. And let me actually move this over a little bit. Let's say 0, 0. And next point, 360. Find your change in Y is going to be plus 60, and my change in X is going to be plus 3. So I'm going to write my rate of change is going to be 60 over 3, which is the same as 20 miles for every per gallon. And so once I find these, I can say, all right, let's compare our reasoning. So if I know this, I would say this. I would say, or I can say, let's double check the question. Based on the information in the table and graph, car A can travel how many more miles? So I'd say car A can travel, if I compare those two, I'd say 5 more miles each gallon, 5 more miles each gallon than car B. And I use my mathematical reasoning to write a sentence that answers the question about it. So be able to find the rate of change for both of those cars and compare what you had. Again, feel free to pause, rewind, replay, ask questions as they come up. For number 10, it says this. It says, during a snowstorm, snow falls at a constant rate and is recorded by a meteorologist. The data is plotted on the graph to the left. Which equation models the representation between the number of hours, x, of a snowstorm and the number of inches of snow, y? So we're going to say, if we're looking at these choices, I could say, okay, first things first, highlight that y-axis, because I want to find where my y-intercept is. So I'm going to say my y-intercept is when x equals 0, so it's going to be equal to 3. That means when x equals 0, my y value is 3. That makes sense because if you look at each of these choices, our y-intercept is 3, and that works out quite well. So now I can say find the slope. So I'm going to say, if I look at my x-axis, I'm going 1 step to the right, and I end up going 1 step up for the next value as well. Let me triple check my work that I have. So if I actually look at my change in y, be careful, even though this is just 1 step, we're saying how many on the y-axis did it move. So this is actually plus 3. So we have to, let me double check this here just a second. Let's say like this. So I want to say this. I want to say my x value, the change in my x value was plus 1, because if I look on my x-axis, I moved 2 steps, but I'm saying I went 1 step because it's 1 unit to the right. And then on my y-axis, a little bit tricky, how many steps did I go up? Well, I went plus 3. So be careful on this one. Make sure you're saying, okay, I moved 1 step to the right, 3 steps up. Again, it's a little weird, but it should work out. So I'm going to say, okay, I write my ratio, so I'm going to say my slope is going to be change in y over change in x. Always write it as a ratio. So I'm going to say it's going to be 3 over 1, which is equal to 3. And so now that I have that, I can write my equation in slope-intercept form. So it's y equals mx plus b. We said b is 3 and m is 3 as well. So that means my answer should be y equals 3x plus 3. So I'm going to say it's going to be this choice right here. For number 11, it says line T and triangle AEC and triangle BFD are shown on the coordinate plane. Notice how both of those triangles, the longest side of both those triangles, are on the same line. And it says which statements are true. So I could say, for the first one, it says the segment BF is equal to the slope of line T. Well, if I need to find the slope of line T, so let's find that first. So slope of line T, I could say if I go from one point to the next, I can find my length. So I could say, if I need to draw a new one, I can say I go 1, 2, 3, 4 steps left. So I said plus 4, and I don't know why it always does that. There we go. Plus 4, and my change in y is plus 2. And you can have any change that you need, but I can say this. I can say my slope, let's do it green, my slope is going to be equal to, I'd say 2 over 4, which is equal to 1/2. Okay, so if I look at the slope of BF, I would say that this is going to not be the same because that's an up and down line, so it's not that first one. For the next one, it says the slope of segment AC, which is on that line, is equal to the slope of BD, which is on that line as well. So I'm going to say this one, second one is good. Again, since they're all on the same line, that slope is going to be the same. Then I could say the slope of segment AC is equal to the slope of line segment BD. So that should be moved down a little bit more. I think it's covering up. So it should say is equal, let me write it to the side here. So make sure you can write this for yourself. So it should say is equal to slope of line segment, let's say BD. So this one, let's find our two. So we have those two. So actually, let's say the slope of line should be just line T. Yeah, sorry, that's where I messed up. So slope of line T. There we go. So we just did that one. So if we're comparing AC and line T, we know those are equal because both of those have a slope of 1/2. So I know that this one is also good. The slope of line T is equal to EC divided by AE. Well, how long is AC or AE? So let's count. Let's say EC is 1, 2, 3, 4, 5, 6. So this is 6, and AE is 1, 2, 3. So it's saying it's the same as 6. Let me write it over here. This is saying it's the same as 6 over 3, which is not the same as 1 over 2. So I'm going to say that this one is wrong because they have the numbers flipped. For the 1, 2, 3, 4, for the fifth one, it says the slope of line T is equal to BF. So let's say BF, let's do purple now. BF is 2, and FD is 4. So it says BF is 2, FD is 4. So this actually works out because it's equal to 1/2. So I'm actually going to select this one as well. So I select that choice, the fifth choice. And then lastly, for this one, it says AE is 3 and BF is 2, which is not what we're looking for because we're looking for 1/2. So make sure you have those 3 selected and those other 3 crossed out. For number 12, it says on the coordinate plane shown, points L, N, and P lie on the same line as F. Write the equation of the line shown in slope-intercept form, and then write a sentence that explains how I got it. So I could say this. So I'm going to say, I want to highlight my y-axis because I want to find my y-intercept. So I'm going to say my y-intercept, which is B, and y-intercept is going to be just 1. Then I can say, if I want to find the slope, I can find actually the length using these triangles shown. So I can say, if I look at this, I'm saying if I want to go from N to P, this is going to be -5, so I go down 5, and I go to the right 2, so this is going to be +2. So if I write that ratio for my slope, let's say this, so I could say my slope is going to be equal to -5 over 2. So then I could say my equation, again use those two things, when I say y equals, my slope is -5 over 2, and I have times x plus 1 because that's what That is what my y-intercept is. So for example, you could say something like, I found 2 points on the line, and I subtracted the x and y coordinates. And so I could say, so I could say something like this, I found y-intercept by looking for the point where it hits the y-axis. And then I could say for slope, we found the ratio of the change in y values divided by the change in x values. So that was, a sentence or two they can say about those two ideas. Then for number 13, it says fill in the blank with one of these 3 statements. So it says consider the graph, or consider the relationship A and relationship B. So we have a graph in the table. It says it's asking for the rate of change, comparing it to the rate of change for A and comparing a rate of change in B. So let's find out. So looking at this one, real simple. I know again, slope is the same thing as rate of change. So I'm going to say, okay, slope is going to be equal to 12 for A, and then for B, let's find out what it is. So what I can do is, let's find our change in Y. So change in Y is plus 12, and our change in X is plus 2. Write it as a fraction. So I'm going to say I have slope of B is going to be equal to, and I have 12 over 2, which is equal to 6. So if I'm comparing these two, I'd say 12 is greater than 6. So let's see, what can I choose for that one? So yeah, I would say that first option is what we're looking for. So you'd say the slope of A is greater than the slope of B. And the last one, for 14 and 15, I'm going to be using this same table. So it says, what is the rate of change in gallons per hour shown in the table? The same idea, same setup. I'm going to find from one point to the next. I only need those 2 points. So I can actually, let me do real quick math for you. So we had to say we went down, so we subtracted. So I subtracted 1,080 to get from here to here. And then for my x value, a little bit easier, I said this is just adding 3. And so what we can do, we can say our slope, or rate of change, let's say a rate of change, slope, rate of change is going to be equal to, I say my numerator is negative 1080 divided by positive 3. And so I'm going to say, because it's asking for gallons per hour, so I need however many gallons for every 1 hour. So this is going to be equal to, and so I can say this is going to be for every, it's going to be 360 gallons for every 1 hour. So that is for number 14. And then for number 15, what does rate of change represent? It's saying for that one, we're just going to say it's the number of gallons drained each hour. So let's say, 360 gallons per hour. So we'd say It's going to be just that first one. So again, super simple. Make sure you're checking those vocab for yourself. That way you're good. And feel free to ask questions at any point in time. And as always, super slam that subscribe button.